Hi, well, this is me just Craig from Team Saint, just doing a quick video on the development of the pneumatic walker. This is the new leg that you're seeing here. This is actually the profile and shape that I'm thinking of actually making the legs on the robot. The leg up here, which is the first one, was really just to test the cam action. So it's basically bits of plastic just chucked together with the two air cylinders there. Okay, on this one you can sort of see I've decided to make it so that then the air cylinder's on top here, and then it pushes on a lever down to the foot. So when that cylinder moves, it actually rotates the foot slightly inwards, and that means that the foot actually will touch the ground. Okay, the idea is that we're relying on the pressure to actually hold the weight of the robot. But the way the foot's been done, it's difficult to tell from this angle. But basically, this part of the foot here is would actually bend. If I bend that down, it works out that it's just slightly out of the fulcrum here, the pivot point on the bolt. The reason for that is to make it easier for the foot to then, with its spring return, go backwards. These are single acting cylinders with a spring return, 20mm diameter, piston diameter, and 50mm stroke. So they're not massive, powerful ones, but they certainly seem to work. As you can sort of see, that I'm using a fairly small pneumatic pipes through to the two control valves here. The control valves are 5-way each, and they have a roller and cam arrangement to actually operate them. The two cams, that one there and this one here, operate the two air valves there. And the idea is that the cams are set at 90 degrees, so every 360-degree rotation gives you a full walking gait, as it were. Okay, compressor. Okay, this is the compressor here. This is essentially a twin-cylinder tire inflator compressor, 12-volt DC. The only thing is, I've done a few. I've taken an awful lot of the plastic waffle that was on there off, and I've also fitted. It's got a switch here. I don't know if you can see it. Oh yes, an on-off switch there, which I'll just turn. Okay, you see it's moving, and then that actually then switches a relay that then actually powers the thing up through the controls coil on the relay. I have this switch here, which is a pressure switch. The bottom line is, if I put the Allen key in here and tighten it up, I don't know if you can see it. Oh, there it is, the Allen key there, and tighten it up. I increase the pressure and loosen that off. I decrease the pressure, so I can actually adjust at what pressure the air is delivered to the unit. Now the cams are then driven. I can just go back to the cams now. There you go. They're the valves and the two lever arms and the cams. They go through to a small gearbox motor, and then down here, just on the bench, is a little tiny manual power supply controller to operate the cam. So if I turn that on, you can now see, go around here, you see the two cams moving, and they operate the two valves. You can just sort of sometimes see inside here. There you can see it moving, and there you can just see it moving. The actual cams are moving around. Of course, this is adjustable, so I can actually reduce the speed of the unit. That's actually powered by 12-volt lead acid. I just measured the voltage, and it is about 12 volts. This one here, another 12-volt lead acid, is actually doing the compressor, and that's about 12.5. So that one's fully charged. This one's sort of not very highly charged. Okay, so what I'm going to do is going to start the compressor first. Okay. Okay. It's sort of. There's a leak, I think, actually on the compressor itself. I think the valves on here leak, so it sort of doesn't come to a dead stop. But if I can actually do this, I'll turn it up, and you can sort of see as I turn it up. So we're up to going to turn it back down again. Okay, and I'm going to turn it down to 3 bar. Okay, that means that this thing is actually running well below 50 psi. Okay, which means it's in the ultra low. Oh, it's gone too far. Back up a bit. That's just about 3 bar there, which is about 45 psi. Okay, so that's actually now maintaining the pressure. So now if I just turn this on, okay, it's a bit noisy, so I'll stand back a bit. You can now sort of see that one moving, and that one moving as well. Right, I'm going to turn it up to full speed. You sort of see the legs are going bonkers there, but their compressor, see on the pressure, hopefully there, it's around about running at about 2 bar, with those two going flat out. I'll turn that back down again. There we go. I'll turn that one off too. Okay. So it basically means that with the thing going flat out, the compressor can actually maintain 2 bar, which is about 20, just slightly over 2 bar, which is about 25 psi, and that seems to be enough to actually operate the legs quite well at full speed. I have a feeling that with an 8-legged robot and 3 of these compressors, that should be enough for me to actually have a situation where no matter what the demand is for the air, 3 compressors should be able to supply the necessary amount of compressed air to operate the legs. What I'm thinking of doing is actually having all 3 basically pump into a manifold, and then from that manifold all the control valves take whatever air they require. It looks like it might go quite quickly as well, so it should be interesting to see for a walker anyway. I might even get about 1.5 to 2 miles an hour out of it, which is pretty good speed. But that's how far I got so far with it. The next stage really is to develop 2 of the legs that will be used on the robots. The polycarbonate you see here, I'm going to use as templates to cut out the legs themselves, probably out of 20mm high density polyethylene, seeing as that seems to be my favourite material at the moment. It seems to be very durable, and if I do eventually use this for a combat situation, I have a feeling that HDPE is going to be about the only thing that will survive. Okay, well, I hope that was interesting for you, and I'll keep you informed as things go, but bye for now.